Alright, in this video, I'm just going to show you how to, this is mainly for my students, how to use the technology that you have in front of you to analyze data, and in particular make a scatter plot, what's called a scatter plot. So we're going to plot data on on a plane, on a axis system. A rectangular coordinate plane, Cartesian coordinate plane, all the same thing. But anyway, we're going to do, it's also called linear regression analysis if it's a straight line. We're going to talk about a correlation coefficient, R and R squared, and then the software we use. So I use Excel and Geogebra, and that's what my students use, and that's what, if you're my student, that's what you're going to use. We also could use Google and Google Docs, but that's a little tougher to do correlation coefficients and things on. I haven't figured it out yet. So we'll stick with Excel and GeoGebra and let's get started. So let's say we have a problem here. And so this problem here is just something I nabbed off the internet or somewhere, I don't know, from a book, whatever. It actually looks like it comes from the USDA, Foreign Agricultural Services Grain Report. And it's pork production in China. And so you have the year 2000 to 2007. So in 2000 there was 40,475 metric tons of pork produced. And then in 2007 there's 54,491 metric tons. So that's a lot of bacon. So what we'll do is let's analyze this data set and see if we can't find, these are the questions you usually see. Use a calculator to find the best fit line. We're going to use Excel and GeoGebra. Use your linear model to predict how many metric tons of pork will be produced in 2025. Use your linear model to predict when the production is likely to reach 100,000 metric tons. So, if it was linear, yes, it's possible that it's not linear, but we'll just assume it's linear for this lesson because this is mainly just to show you how to use Excel. So we'll start with Excel. And so here's Excel. And so I've already entered the metric tons of pork, and I've started entering the years. Now instead of 2000, 2001, I'm going to use 0, 0 for 2000, 1 for 2001, and so on. And what's nice about, if you don't want to type all that in, you highlight it in the bottom corner, let that turn black, that plus sign, drag down, and it should give you the rest of them you need as far as we need to go. I went a little too far, but it could have kept going down. We only need to go to 7. So here's my data. So in 2000 we had 40,475 metric tons of pork produced. So in Excel you can highlight everything. So here's your X and your Y. And in a math class, typically we're just going to use what's called an XY scatter. So we're going to go to here to charts. Oh, there it came up. And yours might look a little different, but mainly we're looking at charts, and then you go to insert a chart. We're going to look at all of them, or maybe other. But I'm going to go through here and look for marked scatter. There it is. So you click on marked scatter, and there's our metric tons of pork production in China. And by highlighting the label, we also got the legend as well. So the title and all that stuff, which is kind of nice. So we'll make this a little bigger. And so the next thing you do is we want an equation for that thing, a regression equation. This is a positive correlation. So I'm going to click the dots, and you can't see it, but we got some layouts here we could choose. But up above there's a chart, and you'll just see the very bottom of it, but you have a choice of add trend line. So we're going to go ahead and add a trend line, and I'll pull that in. And hopefully you can see that. We'll see. And under options, you choose display equation on chart and display R squared values on chart and hit OK. And it'll display that. Now, what you found, I'll move that around a little bit, there's your equation with years, so you should be able to plug in any value you want for X, so that'd be your years, and that should give you your production for that year, knowing that we use 0 for 2000. And then our R squared is your correlation, and our correlation is a 0.9887, which is very linear. This is some good linear data, a pretty good model. Now, if you're really doing this for real, you'd probably look at exponential as well. So you could click on it, do chart, add trend line, and maybe look at your type, and maybe go with exponential or power. You know, you could play around with it and see if you get any better R squared value. The closer to +1 you get, the better the model. So the better the correlation. So that's how I would do this in Excel, and there's other things we could do. But let's go ahead and do this in GeoGebra too. So I'm gonna be a little lazy here, and whoops, I don't know why it just produced a whole bunch of graphs here. I'm gonna highlight my data. Okay, so I'm gonna just highlight my data. I don't care about the labels in GeoGebra. And I'm going to do a Command C or a Control click. I'm using an Apple computer, so things are a little different. But Command C in Apple for a copy. Oops. And then I'm going to pull up my GeoGebra. And under GeoGebra, we need to look under View. And again, you click View, it's up on the top, and you go Spreadsheet View. So sorry that didn't show up, but there's your spreadsheet. So View, Spreadsheet View, and it's your all your things along the top. That's where I got it. And under A, I'm going to click on A and do a Command V, and it should, yep, give me my data points. Okay, and so what we need to do now is, now that we have the data entered, we need to get it over here on this graph. So what you do is you highlight the data, and there's a couple ways to do it, but you do a control click on the data or right click on your mouse. I'm going to do a double tap on my big mouse here, and I want to create a list of points. So you create a list of points, and list 1 should have appeared here on the right, and I'll kind of click on that. There it is. But notice my scale is really off. So when I click on my graph here, and I'm going to go View and Spreadsheet View again and hide my spreadsheet because I'm done with it. And so you click on this Move Graphics View, and you can move it, grab and drag it around. But we need to really drag down so we can find my this 40,000 to 60,000 range. So there we're at 10,000. There they are. And we want it to go all the way to 100,000. And what's nice in GeoGebra is it has a linear regression tool. It's the 4th button to the right, and then you click on the little triangle at the bottom, and you go to Best Fit Line, and you just drag like you're taking a picture. Oh, notice I didn't get them all, so I'm going to hit Escape. Do that again, and make sure you get all the points. There we go. Drag just like you're taking a picture of it. Let go, and there is your regression line. So we'll click on that. It's y equals 2053, which is pretty much the same as what we had in Excel. It might be exactly the same. And what's nice about GeoGebra is that's a little better than what Excel can do, is we can go in here and actually find everything that question asked. So it wants to know when, how many tons of pork will be produced in 2025. So when you go to your GeoGebra, we could just change our X scale to go to 2025, which would be 25, and just stick a point there, actually. Maybe drag it. So right now it's at 24.43, so maybe drag it up to 25. Oh, there's a little too far. Oh, that's close. I mean, you could get closer if you play around with it a little bit. But it looks like we're at 90,000. In 2025, will be around 91,000 metric tons of pork. And you could also get your calculator out and plug 25 into that rule. And it'll produce it exactly for you. And there's some other tricks to get it exactly off the graph. And then it wants to know when will we be at 100,000. So let's just change this scale and move my eye point to 100,000 and see what year it is. So you pull that thing up. Oh, there it was, 100,000. So in 2029 or 2030, right there it shows it, we'll be at 100,000 metric tons of pork in China. So that's just kind of the basics of using some Excel and GeoGebra, and how I use it, I guess, in the classroom, and how I want my students to use it when they're analyzing data. Now, if it's not linear, you've got a lot of things in GeoGebra. Let's say it's an exponential or something. You use this fit, and then notice you've got fit exp for exponent, and so then you'd list your points, like list 1. So fit exp, let's go ahead and just show you what that looks like. Fit exp, and then I'm going to type in list 1 because that's that's our list up here. I just highlighted it. That's what it's called, and you hit enter, and there, if it was exponential, is what it would look like. And notice it actually fits the data pretty well. So there's an awful good chance that this is exponential, it could be exponential as well. And if it was exponential, notice our prediction for 100,000 would be a lot different, be a lot sooner. So that's something to keep in mind. A lot of times growth is exponential, so you want to keep that in mind, depending on what course you're in. If you're in an Algebra 1 or Algebra 2 course, you may not be at exponentials yet, so you're not sure what that means. But if you're in a college course, you better be aware that exponential equations are out there, and it's possible that this is an exponential model. Now, how you find the correlation coefficient for a linear graph is you just type in correlation coefficient, if I can spell it. There it is, correlation coefficient, and then list 1. Hit enter, and there it is, 0.99, and that's for the linear one. There's a r² value for the others, but for now let's just stick to the linear. So 0.99 is my linear correlation, which that's pretty dang linear. That's pretty good correlation. 1 would be perfect. So I hope this helps. Kind of a long video, but it shows you pretty much all we do with it, with data. I mean, we do more, but at least would get you started with data with Excel and GeoGebra. So best of luck, and see you next time.